Think blue, think blue. Okay. And last one. Purple, purple, purple. Think Barney. All right, good job thinking Barney. I like that one. Okay, but now this is called the disappearing rainbow. How did we get a rainbow out of one bottle? Okay, let's see what happens if we go back and use our magic solution number 1. Let's add a little bit of that. Yeah. Maybe give it a little stir. Stir it up a little. All right, we'll let that go. Magic solution number 1 makes it go away eventually. Magic solution number 2 makes the rainbow happen. Now, how do you think we got one rainbow, or a whole rainbow, all those different colors out of just the one bottle? Anybody know? We use something called indicators. These are things we use in a laboratory all the time to indicate the change in what we call the pH. Have you heard of the terms acids or bases? Maybe some of you have, some of you haven't. Yeah. So if you hear acid or base, okay, that's what we're looking at here. So solution number 1 was an acid. Our indicators don't do anything in an acid. They don't like acids. We used magic solution number 2. That's a base. You may have heard of it as lye, sodium hydroxide. That one changed all of our different indicators. And what we did was we used different indicators in each beaker. So in the red beaker, we had phenolphthalein. In the yellow one, we had something known as p-nitrophenol. I know, big words. And then in the blue one, we had thymolphthalein. Now, do you know how you make the other colors? How did we get the orange and the green and the purple? How do you make green?
You mix the primary colors.
Right, so green was the yellow and the blue. So we took the p-nitrophenol for yellow, the thymolphthalein for blue, and mixed them together. We did that before you guys got here. That's why it took a little bit longer for the color to appear. It kind of dried up on us a little bit, but it got there eventually. So this is what we use in the laboratory all the time. When we want to know what something is, if it's an acid or a base, we put that in there. And do you know, you probably have stuff in your own home that will do this. There are things that you may have in the refrigerator that will change colors in an acid or a base. And one of them is red cabbage. Who likes red cabbage?
I do!
You do? All right. Okay, and you know what? Red cabbage is good to eat and it's fun to play with. Yeah. So you take the juice off of red cabbage, and then you go find something like lemon juice and mix into it. It turns all sorts of cool colors. Now, bases, you're probably not going to have a lot of those in the kitchen, so you might get your parents to help you with that if you want to look for those. But you can see what something is by mixing that in. And you know what? Blueberries will do it too. Take blueberry juice, it'll change colors in that stuff. Okay, so that's our disappearing rainbow. Okay, now the next one we've got up, this is one we kind of had build at the beginning. So the question was, have you ever wondered how, now we're not going to actually make explosions for fireworks. So have you ever wondered how they get those colors into fireworks? All those different colors. And that's what we want to look at. So the way we make colors in fireworks is we use different metal salts. So if you know what a metal is, what we have up here are salts that have different metals in them. We've got things like sodium and lithium, barium, potassium. We've got different things that when they get hot, like they do in a firework, it excites something called electrons in there. All the little electrons dance around, they gain energy, and then eventually they relax. And when they relax, they emit energy. They're just, okay? So it's like sweat coming off of them, okay? And when that happens, it's a particular wavelength of light. We see it as color. Okay, so now we're going to bring the lights down a little bit. There'll be a little bit of light coming in out of the hall, but if you're scared of the dark, find your buddy, grab them. Okay? So all you kids, grab your parents. They're going to be scared. We're going to bring those down. For some reason, it didn't go all off. So, all right, we'll try that. Okay, we'll bring those down. And where's our lighter? Okay. Yep. All right, let me make sure we've got it good. Okay, I'll light that from that end. There we go. takes a little bit to warm up and get it going, but you should eventually start to see a little bit of color appear. So now you're starting to see some of those colors that you get. Okay, so now you see kind of that purplish red, you see a really bright orange red, here's a nice yellow, here's kind of a deeper orange, bright orange, here's a nice blue that you're getting. Now the blue that you're seeing in all of them is the methanol burning. We put methanol in these to dissolve them. Okay, so a little bit of flambe there. Okay, here's a nice green, so you've got some copper going on, you've got your strontium and your lithium in here. Okay, the bright orange that you're getting, that's just plain old sodium. You could do that one at home. Okay, so you take a little bit of some kind of alcohol that will burn, you put a little table salt in there and mix it up and light it, you get a really pretty orange. If you've ever seen those colored logs like they use in fireplaces, this is what they do. They make a solution of these metal salts, soak it in there and light it up. Okay. Well, that was a lot of methanol. These are going for a while, so we'll let those kind of burn themselves out. Okay, so the next time you see those fireworks, now one of them we don't have in there, the bright white that you see, that's usually magnesium. We don't have that one in here. So the magnesium doesn't always turn as white with the methanol. But magnesium metal burns really bright white. All right. That out. There we go. All right. Okay, we're going to go ahead and leave the lights down just for a minute. The next one we're going to show you kind of deals with the same idea. This one dealt with fluorescence. So the energy was fluorescing here, and we were seeing all these different colors. Now we're going to look at chemiluminescence. So this is chemical light. So luminescence is light. Luminol you may be familiar with if you watch these like CSI programs, things like that, true crime stories. They use, now luminol is actually a chemical. You can see right here, here it goes. Luminol is what they use at crime scenes to look for blood. So what we're mixing here, we've got a combination of this chemical called luminol, hydrogen peroxide, to catalyze that reaction. And as it reacts, it gives off energy in the form of light. Okay, so a lot of reactions will give off heat. When something burns, you feel heat. This gives off light that you can see. And in the presence of a catalyst, like iron that we find in hemoglobin in our blood, it catalyzes this reaction and it glows. So scientists and criminologists can use that in a crime scene. They can go in and spray a mixture of luminol around and they turn off the lights. And if there was blood there, even if you can't see the blood in visible light, there's still traces of it there. There's enough iron that will start glowing. And so they can see things like bloody footprints or bloody fingerprints. And they can determine if perhaps a crime occurred in an area. So, nice long blue. All right, we'll bring our lights down.
Whoa, it looks perfect.
Sorry. Okay, I got to play with the lights to get them figured out here. All right. Okay. Okay, the next one we're going to show you is something called green vest explosion. Now, you may or may not be familiar with this around here. Anybody who's from places like Kansas or Iowa may be more familiar. Places where you've got lots of green up there. Texas, Kansas, here's a couple of examples. There are cases where you've got a silo filled with green, you're pouring it in, you build up dust, and there's this explosion. Now there's nothing in there but the grain.